Hello everyone. Today we're going to learn about how to calculate the sum of the first nth terms, of a geometric sequence. Um, and before going to the main section, I want to have you revise some important definition about a geometric sequence. And my name is Nguyễn Thị Nga. My faculty is mathematics. My student number is on the board. Okay, so now let's recall about the definition of a geometric sequence. For example, when I have a sequence UN and I have a sequence UN, okay, and then I have the first term denoted by U1, and the common ratio is denoted by Q. Okay, yeah, I can write down for detail. I have a sequence UN. Okay, and the first term I denoted by U1, and I have my common ratio is Q. And then my geometric sequence is divided as UN equal UN minus 1 times Q. Okay. For n is greater than or equal to. Okay. N is greater than or equal to. And it means that when you have a sequence which has the probability, what has a property like this, it is called a geometric sequence. Okay, you have a sequence with this property. Yeah, this is called a geometric sequence. For example, I have a geometric sequence here. Example, I have a geometric sequence here with U1 with U. Okay, I will list them. With like 1, okay, 3, yep, 9, 27, okay, and 81, so on. Okay, and you can recognize that my sequence is given by U1 equal 1 and the common ratio equal. Yeah, you can take the uh, success mm, the successive. I mean the yep, you can take a ratio, a proportion of UN over UN minus 1. For example, I take 9 over 3 and then I got 3. And so I can conclude that my common ratio is 3. Yep. And and then we have another thing to recall is the general formula. No, the general term of a geometric sequence. Okay. The definition, I think it is definition 2. Yeah, it is about the general the general term. When I have a geometric sequence like this, yeah, when I have a geometric sequence like this, I can find out the general formula to express an arbitrary term in this sequence in terms of U1 and Q. And it means that I can have UN equal U1 times Q to the power of n minus 1. And for n is greater than or equal to. Yeah, we have proved this We have proved this property in the previous lesson, so I just want to recall them. Okay, for example, we can write example, I can write them. Then I can find out the general term, the general formula for uh, for an arbitrary term in my previous example. Yep, because the UN equal 1 and Q over 3, yeah, as we have found before, right? So I can conclude that. Yep, so I can conclude that the one, two, the general term of my sequence in the example 1 is UN over 1 times 3 to the power of n minus 1 and equal 3 to the power of n minus 1 for n is greater than or equal to, right? And that's all. I think this is enough for us to go to the next part. It also the main section of our lesson today. It is how to today, okay? It is how to compute the first n term, right? The first n term of a geometric sequence. And definitely you cannot apply the formula to compute the first n term of a arithmetic sequence to compute a geometric sequence, right? Because these two sequences have the difference. It they don't have the same property, okay? So we cannot use it. So how to answer this question? Okay, I will guide you to find out the general formula. Okay, so now let's recall what is the first n term with the sum. Yeah, sorry. How to compute the sum of the first n term. The question is how to compute the sum of the first n term of a geometric sequence. Okay. Explicitly it as n equal u1 plus u2 plus un. Okay, this is our first n term of my geometric sequence, and I can rewrite it based on my general formula for an arbitrary terms in a geometric sequence. It means that un equal un and u2 equal un time q, and yeah, I can write that too. And u3, yeah, I can write u3 here. u3 equal u1 times q to the power of 2, and so on until un, right, over u1 times q to the power of n minus 1. And then, yeah, uh, I can rewrite. I can factorize it as u1 times 1 plus q to the power of 2 until q to the power of n minus 1. Okay. There is my Sn. Yep. And then I want you to help me to compute Sn times Q. For Q is a common ratio. What happened? What happened if I time Q through my Fn's? Yeah, I can see that. Yeah, I will time Q to into the second factor. Then I got Q plus, yeah, my Q in the previous formula now is turned to Q square, right? And plus Q cubed and plus so on Q to the power of n. Okay. Yeah. So yeah. So in the next step, we compute as n minus at n times q. Okay, because I say we have the common factor is un. Okay, right? And beside, I also have the common terms in my sum, in my first sum. Yeah, when I minus at n, is subtracted by at n times q, then I see my q is, I mean, the two terms are eliminated, right? Qn, and this process continue until, yeah, and finally I got 1 minus q to the power of n. Okay. And I make some small changes here. That means that I got at n times 1 to the minus q equal u. Sorry, it's u1, not un. U1 minus u to the power of n, and then finally I can got my formula, my Sn equal u1 times 1 minus qn to the power of 1 over q, right? And yeah, definitely q is different from 1. Yeah, we have find out the general formula of a geometric sequence. Yeah. How to compute the sum of the first n term of a geometric sequence. And my question is, what happened if, yeah, if my common ratio is 1? What happened? Okay. Okay. Oh, when q over 1, you see, for example, um, I take a random geometric sequence with q over 1, with u1 equal 5, for example, and then the next term is 5 times n is 5, and then 5, 5, blah, 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 blah. Yeah, so yeah, yeah, you can recognize that uh, the every term in the geometric sequence is the same. So at n we equal u1 times n. That's all. This is how to compute the sum of the first n term when q over 1. Okay, so let's do a small practice, right? Practice. I have a question 1. I give you a geometric sequence, right? A geometric sequence un, okay? And no. I want you to compute that my Sn equal 1 plus 1 over 2 plus 1 over 2 square plus blah blah until plus 1 over 2 to the power of 9. Uh, and when you see this term, you have to notice that this is a sum of the first 10 terms of the geometric sequence, right? Like easily I can recognize that as n, yeah, no, sorry, is it not at n, s, yeah, I can recognize that solution. I can recognize that s. Yeah, I can recognize that as the sum of the first 10 term of a geometric sequence With U1 equal 1, right? And the common ratio Q equal 1/2. So now when I notice that, I can apply my formula. It can be the first 10 terms, the sum of the first 10 terms, right? And then my S10 equal, right? U1 here equal 1, yeah. 1 times 1 minus Q is 1/2 to the power of 10, okay, over 1 minus 1/2. And then I got, and I have computed it at home, and my answer is 100, no, 1023 over 500 and 512. Yeah, this is my final answer. Yeah, there's there's. So, and thank you for participating in this lesson. Thank you.